Alright, so in section 8.3 you have to learn about dot products. A dot product is also called a scalar product at times, but this is how it goes. When you want to do the dot product of two vectors, so let's say I was doing u dot v, and it's important to notice that it's a dot. It doesn't, you say dot product, you don't say the multiplication of two vectors, because there is something later called a cross product, which will be u cross v, like that. So it's called a dot product. Don't just say you're multiplying two vectors. Alright, so what you will do is you will multiply the x parts or portions, so a times c, and you will add b times d. So what you will get will be a scalar. It'll be like a number that you'll get. So when I do that over here, I'll be multiplying 3 times 1, adding negative 5 times 4, and so I will get 3 plus negative 20, so I get negative 17. So this dot product is used in some formulas and so forth. Some things about dot products. U dot v is the same as v dot u. Like they're commutative. You can do them in any order. U dotted with, say you're doing v plus w, is the same thing as like distributive property. U dot v plus u dot w. So I mean, you could just, why would you do that? I don't know, but like, you know, in different situations, maybe you want to do something first. You're multiplying a constant, like a scalar, times u dot v. What you can do is you can multiply that thing with u and then dot it with v, or you can multiply it with, take u alone and do c times v. So it's just like multiplication in a way. Like, you know, like if you have 3 times 2 times 5, you could do 3 times 2 first, multiply it with 5. Or you could do 3 times 2 and 5 together already, like 3 times 10. So, you know, or you can just do 3 times 2 times 5. All right, so last one, 0 times a vector, dotted with a vector, is 0. And last one, u dot u is going to be the magnitude squared. Because if you're dotting something with yourself, you are basically just squaring each part and adding them together, right? Like if I take 3 comma 2 and I dot it with 3 comma 2, I'm getting 3 squared plus 2 squared. What this is saying, this is like the magnitude, right? If I was doing the magnitude, I would have a square root around it, but what's happening is that square root's not there, so it's squaring out of it, right? So anyway, it's just like a rule. Okay, so let's use them down here a little bit. U dot v, so I'm going to figure that out first, so I have to dot these together. So to do negative 2 times 3, so negative 2 times 3 would be negative 6 plus negative 20. And I have to multiply that by w, so w is 0, 2. So let's see, negative 26 times 0, 2. So I end up getting 0 and negative 52. Alright, u dot 2v, so u is negative 2, 4, dotted with 2v. Well, that would be 6, negative 10. So I dot those, I get negative 12 plus negative 40, so negative 52. So my answer, my problem is a dot product to end with. I end with a number. But here is a dot product times a vector, so it's a number times a vector, so it's a vector. All right, so the angle between two vectors. There's a formula for this, and it goes like such. Cosine of your angle is equal to the dot product over the magnitudes multiplied together. Okay. So it's a formula. We're just going to go ahead and execute it here. So I want to find the angle between these two vectors. So let's draw out what we're getting here. So 2i minus 5j, so 2 and down 5, so it's this vector here, I'm just estimating, right? And u is negative 1 plus 3, so maybe about there. So what this is going to do for us, it's finding the angle between these two vectors right there. So it's a pretty large angle. All right, so the cosine of my angle is the dot product of these two things. So w dot u, let's figure that out. So that's going to be 2 times negative 1 plus negative 5 times 3, so negative 15, so that's negative 17, over each of their magnitudes. Well, the magnitude of w is going to be the square root of 4 plus 25, so 29, and the magnitude of u is going to be the square root of 1 and 3 squared each. So square root of 1 squared is 1, plus 3 squared is 9, so 1 plus 9 is 10. All right, so I got radical 29 and radical 10 down here multiplied together. Okay. All right, so that's 290, right? So cosine theta equals negative 17 over radical 290. All right, so just grab your calculator, and if I want the angle, I have to do second cosine of what? Negative 17 over square root of 290. Oops. Okay, so the angle, as we expected, pretty large, is 176.6. Okay. All right, parallel vectors. So remember, parallel vectors, they go the same direction. All right, so they have the same angle, right? So an example of parallel vectors are going to be scalar multiples of each other. All right, remember, parallel vectors can also go the other way. They can be longer, like that. This is parallel to those two. All right, so an example of parallel vectors might be this. Let's say vector u is like 5, negative 3. Let's say vector v is negative 10 and 6. So notice that all I did to get from one to the other, if I multiply vector u by negative 2, if you multiply this by negative 2, you get that. So these are multiples of each other. They're going to have the same slope to them. They might be going in different directions, but they have the same angle to them. Okay? So perpendicular vectors. So perpendicular vectors obviously have a right angle right here. And so perpendicular vectors, let's go ahead and draw these two. So negative 4, 6, so 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, so right about there. Oopsie. Well, just pretend that's there. And then over 3 and up 2, so there. I mean, so it looks perpendicular, but there is a rule. Perpendicular vectors do this. Their dot product is 0, okay? Because their slopes are opposite reciprocals, so basically they're going to cancel each other out when we do their dot product. So if I do negative 4, 6 dotted with 3, 2, I will get negative 12 plus positive 12, so I get 0. So dot product is equal to 0. That's a smiley face in there. Okay, so that's a big rule. Dot product equals 0. Scalar multiples. Parallel vectors are scalar multiples. Okay. All right. I have to break this up into two parts. Let's see. Projection. So when you do projection, you know, when you have motion here, this like a vector acting this way, it has two pieces to it. You know, this vector in this direction and that vector in that direction, are the addition of those two vectors is the result right here. So we're used to adding two vectors to find the result. We've done that before. But it's also useful to do the reverse. So basically, when you know what happened and you want to know what two vectors made up that action, all right? So knowing how an object moved and finding out how or why it moved that way. In other ways, what vectors created that motion. So when you decompose the resultant vector into the sum of two vector components, so this part down here, this vector at the bottom, like the shadow of this action that you made, the shadow down here is called a projection. Oh, I have it right here. Projection of u onto v. All right. So if it's flat, it looks like this. So this shadow, like right here, is called a projection vector. And remember that this projection plus w makes u. Right? So here's the formula for it. This is the formula u dot v. So you do the dot product of vector u and vector v. Right? And then on the bottom, you do the magnitude of v squared, and then you multiply that by v. Because v is the direction, like the bottom, like the thing that your shadow is falling on. It's the direction down below. Right, so your projection is just a multiple, this is just a number, times vector v. So it's just a length down here along vector, the same direction as v. All right, So let's go ahead and just like evaluate this formula right here. So u onto v, so the projection of u onto v, that's how you write it. You do the dot product on top, so I'm going to dot these two things, so I get 18 minus 10 is 8. And on the bottom, I do the magnitude of v squared. So the magnitude of v is the square root of 36 plus 4, so that's the square root of 40. And remember, I'm squaring that. So if I square a square root, the 40 just pops out. And then I'm multiplying this by vector v itself, so 6, 2. So basically, I have 8/40ths times 6 and times 2. So what is that? 1/5. So this turns into 1/5. So basically, I get 6/5 and I get 2/5. Okay. All right. Let me see if I can pause this, and I think I'll just have to break this up into 2 parts instead. All right. Yeah.
Should I have to